All right, let's take a look at our lesson on graphing rational functions. We will be using a calculator today, so if you would get your calculator out, we're going to do parts of this lesson by hand and part with a calculator. So let's remind ourselves what a rational function is. It's a fraction made up of polynomials. There's a polynomial in the numerator, polynomial in the denominator. So these are the things that we need to do as we work through graphing. The very first thing is to factor and simplify. If we have a factor that cancels out, it just cancels out, then there's going to be a hole in the graph. Okay, and we have an example of that. And then from this point on, this is really critical, from this point on you should use the simplified equation. Do not ever go back to the original. So let's talk about how you would, this little bit right here is how you'd find a hole. So whatever you cancel out, you equal to 0 and solve for x. And then you plug that value in for x to get the y value. Okay, and we'll go through, we have an example with a hole, so we'll be more specific with that. The second thing that you're going to do is you're going to find your vertical asymptotes. Now, the vertical asymptotes are like those little dotted lines. They're vertical, and they happen when the denominator is 0. We don't want the denominator being 0. So that's what a vertical asymptote. We would set the denominator equal to 0 and we solve for the variable, which is typically x. Horizontal asymptotes, or horizontal dotted line. And so for horizontal asymptotes, what we're going to do is we're going to make the degree in the numerator equal to the degree in the denominator. And if they isn't that way already, then we're going to add a 0 term in and make that happen. And then our last step is to divide the leading coefficients. So let me give you some examples of that. Let's do a couple of examples. All right, so let's say we had 2x cubed plus x squared plus 1 over x cubed plus 5. Okay, we can see right here that these are the largest exponents. We know that there's an implied 1 in front of that x cubed in the denominator. And so what we're going to do is we're going to take the coefficients of those largest exponents and divide them. So my horizontal asymptote in this case would be y equals 2. Okay, this would be the equation of the horizontal asymptote. All right, well, let's look at another example. Okay, what if we have, let's say, 5x cubed plus 6 over 2x squared plus x plus 1. Okay. So here we can see this is the biggest exponent, and I don't have a corresponding x cubed in the denominator. This is when I'm going to use this technique where if the thing will behave itself, this is where we're going to use the technique where we insert a 0x cubed down here. Now some students get really upset about inserting a 0x cubed, but 0 times anything is nothing, so basically it's just like a placeholder. I'm not really changing the value of anything. And so now I have matching, so it's matching. And so now I divide 5 divided by 0, which we know we can't do that, or we can't divide 5 by 0. So this means that there is no horizontal asymptote. Okay. The last example, let's look at this example. what if we had, let's say 2x squared plus 5x plus 1 over 5x cubed plus 6. Let's say we had that. Okay, so let's identify the largest exponent. It's this one right here. Now I don't have a corresponding x cubed in the numerator, so I'm going to insert one in. So 0x cubed. It's going to hang out there. Now I have matching. They're matching. So now what I do is I divide the coefficients. And so in this case, I'm going to get y equals 0 over 5, which is 0. That's going to be my horizontal asymptote. And those are the only 3 types that you will get. You're either going to have, like the first example, they're going to match, you just divide them. The second example, the exponent is larger in the numerator. Or the third exponent, or excuse me, the third example is the exponent is larger in the denominator. And those are our options. So let's look at what other things we need to pay attention to when we're graphing. We would find the x-intercepts. If we're doing this by hand, we would plug in a 0 in the y position and solve for x. And our point would be written like this. Now we're going to use a calculator to do this today, so we won't be doing this by hand. And the y-intercepts, we're going to substitute a 0 in the x position and solve for y, and it would give us a point like this. Again, we're going to use a calculator for those things. Domain and range, we've been doing quite some time. The little nuances here are that we need to be sure that we exclude any x values for holes and vertical asymptotes, and exclude any y values for holes and horizontal asymptotes. So those are just some notes we need to just pay attention to. And then since we're going to be using a calculator, we won't really need to do step 8 to finish the graph. We're just going to use the calculator to graph for us. All right. So let's take a look at our first example. Okay, so what our job is we need to simplify first, always. So, which means factor. I'm going to have to factor this. This numerator is the difference of perfect squares, which probably by now we hopefully are accustomed to. We remember we did this when we were doing multiplying and dividing. We factored and then we crossed out any common factors. When I cross those factors out, what has happened is it has just created a hole. Okay, it's created a hole. And so that's what happens. So I'm just going to say this again. If I cross 2 factors out, one in the numerator, one in the denominator, this creates a hole every time. So how do I find the location of the hole? Well, the x value of the hole is going to be where I set this factor that I crossed out equal to 0. So x is going to be at -2. That's going to be the x value of the hole. Now for all the rest of our work, we're going to be dealing with this. We're going to be dealing with the simplified. This is the simplified version. And this is the equation that we're going to be working with. So when I get the simplified equation, so now to get the y value of the hole, I'm going to plug in the -2, substitute in for the x. So let's just do a little scratch work here. So I've got -2 minus 2, f of x equals, actually f of -2 equals, and that's going to give me a -4. So I'm going to go ahead and go over here on the graph, and I'm going to go to -2, -4, and I'm going to put a hole, just so I don't forget. All right, so now since this is just a line, this is the equation of a line, and it has a hole in it, it's not going to have any asymptotes. Now it is going to have an x and y intercept, but to get those, what we're going to do is we're going to go to our calculator to finish out this problem. So let's pull up our calculator. And I'm going to put the entire, we're going to put the whole graph in, not the simplified graph, just so I can show you some things. So we'll go to our fraction, and our original equation is x squared minus 4 over x plus 2. Okay, so let's graph this. So we can see it is a line. You know, my x-intercept is right here. And so to find my x-intercept, just to remind you, we would go to our menu, we would analyze graph, we would find the 0. So we would put our lower bound to the left of the 0, our upper bound to the right of the 0, and we see that we have a 0 at 2, 0. Our y-intercept is right down here at -2. And so it appears that it's just a plain old line and I don't see a hole. That's kind of the negative of the calculators. The calculator can't really show holes. But I'm going to show you on the table where you can tell, so we know there's a hole there. We've already calculated it. If we go to menu, table, and we just want to a split screen table, we want to take a look at it. And if we go up here, we know the hole is at -2. We can see that there is no y value at -2 in our table. It appears that there's one here because our calculator doesn't have the ability to show a hole, but we can see it in the table that it is a hole. Okay, so let's get rid of that table. And let's go back to our document so we can graph this. We know we calculated that our x-intercept, we let the calculator do it, is at 2, 0. And our y-intercept was 0, -2. So let's plot those. 2, 0, and 0, -2. And then we can finish out our graph. So just looking at the graph, we want to look at it to determine domain and range. So I'm looking at the graph, I see that my domain is going to go from -infinity and it's going to leave out -2, right, because there's a hole here, and then from -2 to infinity. My range is going to start down to -infinity and come up to -4. It's going to leave out the -4. And then it's going to pick up on the other side of -4 and go to infinity. All right, and that is our first example. Let's do one more before we start practicing on our own. So on this one, we certainly want to try to factor, or we're going to factor and see if there's anything that will cross out. The top is difference of perfect squares, or the numerator. The bottom or denominator is the difference of perfect squares also. And you can see nothing crosses out. And the only time we get holes is when something crosses out. So there are no holes, there's none. Okay. For vertical asymptotes, we're going to do the vertical asymptotes first. For the vertical asymptotes, and let's just make little notes on over here, I'm going to call it VA, vertical asymptotes. What we do is we take the denominator, which is x minus 2, x plus 2, and set it equal to 0. That's going to give us our vertical asymptotes. And if you recall, that theorem we looked at is if I multiply two things and get 0, one of them has to be 0. So I set each factor, or bubble, equal to 0. And I get x is 2 and x is -2. So those are my two vertical asymptotes. I'm going to put them right down here. X is 2 and x is -2. So let's graph them. Here's x is 2, just dotted lines. Here's x is -2. Okay, great. We have those. Horizontal asymptotes are when I take the highest exponent, which is 2, and I'm going to go back to the original. I don't want to do the factored one. Let's go back to the original. Here's my highest exponent, it's right here. I see that the number in front of x squared would be a 1. So I'm going to divide the exponents, 2 divided by 1, and that gives me a 2. So my horizontal asymptote is at y equals 2. Now let's graph that one. So y equals 2 would be right here. Fantastic. So now that we have our template set up, or the information that we need, we're going to go to our calculator, and we're going to get the rest of the information off of our calculator. Our x-intercept, our y-intercept, and then we'll graph it on here, and then we'll look at our domain and range. So let's go back to our calculator. Let's go up here, and let's get rid of that 1. Okay, so let's put in another one. Okay. All right, so we've got 2 times, and then open a parenthesis. We've got x squared minus 9, x squared minus 9. And then in the denominator, we have x squared minus 4, so x squared minus 4, and then we hit enter. So there is our graph. All right, very interesting looking. We can see from the graph, you know, we have a horizontal asymptote at 2. You can see right here how it just, these little pieces right here, I call them little L's. These are kind of upside down L's. They come up and they approach this asymptote, but they're not going to cross it. In later classes, you will see how they can cross a horizontal asymptote, but we never ever can cross a vertical asymptote. And so you can also see that we've got our asymptotes would be right here at 2 and negative 2. And our calculator doesn't show asymptotes, so that's why we need to calculate those by hand so we know what's going on. So let's look at what would this value be. Let's do our menu analyze graph. We're going to find our zeros. So let's do this 0 first. Okay, that 0 is at negative 3, 0. Let's find our other one. So this 0 is at 3, 0. Okay, so those are our 2 zeros. For our y-intercept, it actually, I don't have a button for y-intercept, but y-intercepts are very easy to find. We'll go back to the graph, to our page, and I'll show you how to do a y-intercept. It looks like it's at 1, 2, 3, 4. It's between 4 and 5. Okay, now I could go to my table. That would give me a y-intercept. That sounds fun. Let's do that. Let's go to our table, and we want to find, so this would be where x is 0, right? Where x is 0, we want to know the y value. So here x is 1 and 2. Let's just move up a little bit. There we go. When x is 0, y is 4.5. That's nice. It's kind of even. So that's going to be our y-intercept. We let our calculator do that as well. We could do it by hand, but why not use the table? That sounds like a fun idea. So we've got now both of our x-intercepts and our y-intercept, and we see the way that the graph looks. So let's go and copy that on our page. So our x-intercept, as you recall, we have a negative 3, 0 and 3, 0. So let's plot those. So here and here. Okay, great. And we know that those graphs were like little L-looking things. So let's just fill in that. And so we just go up to the asymptotes. We don't crash through them. No crashing through. Our y-intercept was at 0, 4.5. So 0, 1, 2, 3, 4.5. So right here. And it looked like a little parabola looking thing there. It's not a parabola, but it looked like a little parabola looking thing. Okay? So now let's do domain. So domain, our x values start at negative infinity, and they go to negative 2. We kind of stop off at negative 2. That vertical asymptote doesn't allow us to have a point there. And then we pick up on the other side of -2 and then go to 2. And again, this vertical asymptote doesn't allow us to use a 2. Then we pick up on the other side of 2 and go to infinity. And there is our domain. Our range, we start down at -infinity, and you can see we go up until we get stopped by that horizontal asymptote at 2. And then we would have 4.5 to infinity, which would finish this out.